You are now unmuted.
Right. I'm happy that we are now increasing in numbers. So let's start our lecture, and I'm sure that you have covered some of the concepts with Ms. Chinyoku, and I'm going to cover practicals. And the practical that we're going to do today is one of the simplest programs in ALP. Please confirm that you're hearing what I'm saying here, because I don't want to go alone. I don't want to go by myself.
Muted.
I'm sorry. I was just answering my call. I was saying today we're going to have a very simple ALP program. A very simple ALP program. And I'm sure that I've given you some takeaways to do at home or wherever you feel comfortable to do them. So I will start by giving you a takeaway. I will start by giving you a takeaway, and I think it will be good if I type the takeaway here on the public chat, because some of you may not get the sound like what others are getting. So this takeaway that I'm giving you, is part of what we are going to do in this lecture. And besides being part of what we're going to do in the next lecture, it also helps you to learn how to come up with an interactive assembly language program. So that's what I'm going to do here. I'm going to type the takeaway. Write an ALP program that accepts, it's a simple takeaway, a string input from the user. Right, as simple as that. So you are supposed to write an ALP program that accepts string input from the user. It must accept string input from the user. So that's the takeaway that I'm giving you right now. Go into this takeaway, and I'm sure that you're going to use the answer to this takeaway somewhere when you try to change the program that we're going to write today. Because once we write the program that we are supposed to write today, you go and apply this takeaway to the same program that I'm going to give you right now in few seconds. So since I'm observing that I'm having a few number of this class, a few number of students from this class, I'm recording this video so that I can upload it on YouTube channel, and it can be accessed from this big blue button platform. So make sure you tell your colleagues and share the links to them, and I'm going to upload this on the channel. So don't be surprised, because I'll definitely start by sharing my screen and give you the content that I want to give you. Right, I hope everybody is now having access to the screen that I'm sharing with you. Please confirm through the public chat, or you can unmute yourself and say yes, we can see your screen. Right, please confirm that you are seeing this screen. Yes, that's fine. So since I'm going to upload this on the YouTube channel, if you miss something You can still visit the YouTube channel and revisit the areas that you have missed out. You can add this as one of the sources in your research, and then you can find more information from Google. You can find more information from any other source, and then combine it with whatever that I'm going to talk about. You may find an efficient and one of the best effective way of doing what we are doing here. So if you find the best solution, or if you think that your own way of doing what we want to do here is the best, you can share with us in the comment section, or you can email a solution. If you think a comment section is not enough, you can email your own solution, and I can find a way to share with others. So that's how we learn. So if you get, once you get to the channel, make sure you subscribe, you click on the notification bell, you like, you comment, you share, and that's it. Like, comment, share, and subscribe. So what we are going to do is this. I'm going to give you a sample ALP program, right? It's two sample ALP programs that I'm going to give you, and if you hear them, you might say, no, this is one of the toughest ALP program to write. But no, these two are the simplest programs to write in ALP. These are the simplest programs to write in ALP. So don't worry yourselves, relax, and sit back, relax, and watch. If you have your own x86 emulator, be prepared to open it so that we start to write the program. Be prepared. But I will try by all means to explain every piece of the code so that you understand each and every piece. It's better to understand one item than to do 1000 items and you understand 0 out of 1000. So it doesn't make sense for me to say I have covered 70 million concepts, but none of them is understood by any one of the class members. So I will go as slow as I can so that you understand everything. So write an ALP for 8086 to convert uppercase string to lowercase. So what is it that we are supposed to do? Remember the takeaway that I gave you. Write an ALP program that accepts string input from the user, right? So you are supposed to write an ALP which prompts the user to enter a string, and then after entering the string, the ALP itself, it then converts the string from uppercase to lowercase, or it may convert it to from lowercase to uppercase. So we're going to cover both from uppercase to lowercase and from lowercase to uppercase. So you understand how the computer or how the CPU is actually doing these conversions. We'll go deeper to lower level, that is to the hardware or to the mathematical operations that are being done by the CPU. So ALP for 8086 to convert lowercase string to uppercase. So these are the two ALP programs that we're going to cover today, and I'll explain each and every piece of the code so that you understand everything and you do not claim or forget all the concepts that we're going to cover here. Right. So we start with, so here what I'm going to do is I will show you each and every piece of code, tell you what it means as we go, and then later on we open the M8086. We discuss about the code that we will write, and then after writing the code, the next thing that we will do is emulate and run it, so that we observe whether we have done it correctly or we have missed something. So the first thing is we start with the data segment. If you want to be advanced, you may start writing the code in your x86. So I will just give you some few seconds that let me just give you 10 seconds to open your x86. So the 10 seconds begins now. Open up your x86 or any emulator that you are using for x86. Open your x86.
You are now muted. You are now unmuted.
Once you are done, just type in we are done opening, so that if I find that some of you are done opening the yes, that one has opened it, and we are going to use the com template so that you start typing the code, or you can delete everything from the template and start writing the code that we're going to type in here. By the way, when are you coming for face-to-face lectures? When are you coming for face-to-face lectures? Ah, that's great. I'm happy that you are coming this Monday. I am happy that you are coming on this Monday. Right, that's okay. Let's now run right, let's now type the following code. So that's what we're going to do here. We type that. So let me explain this code. Please pause typing. I will give you time to type this code, and I will ask you to respond once you are done typing, like what we did on opening M8086. Zino easy, zino na kids are easy. Right, let's do it this way. Here is just a comment where I'm saying 8086 ALP Programming Practical by Engineer Shexa. And then what we do now is we have our segments. We have data segment, we have code segment, extra segment, and stack segment. So each and every segment has got its own functions, and it's used differently from what we use another segment. So 8086 has got data segment, and data segment is the one that is defined here when we say dot data. Here on dot data, what we are doing is we are dealing with data. In C or Java or any other kind of programming language, what we do is we globally declare variables. Like we say int a is equal to that, and maybe pi is equal to that. That's what we are doing here. In data segment, we define all the variables that we want to use in our program. And when we define variables, we use directives, which are not the codes. That is why you will see that when we start to emulate our program, the variables are not going to be executed as instructions, but they are directives. And the directives that we use when declaring variables are like define byte, that is db, as you can see from this code. It's saying string db, and string is the name of the variable. String is the name of the variable that we have declared here, and db is now telling us that we have defined a byte, and I'm sure everybody remember from the previous lectures. If you don't remember, if you missed the lectures, you can open the YouTube channel and watch previous lectures. And then we say we initialize the value for this variable that we have declared, and the value for string is Shexa Martin, stays at house number 123 Malta Road in Harare, Zimbabwe. So that's string variable declaration and initialization. So this one is just a comment. So what you actually need to do is you just say dot data. Yes. You just say dot data, and then from that you type another instruction, which is string defined byte, and inside the quotes you put your string. But in this case we have this string, so if you want you can have your own kind of string inside there, and make sure that you have a $sign at the end of the string. But the $sign is the one that I'm going to use to check whether we have reached the end of our string or we haven't reached the end of our string. So let's just pause for 3 minutes. The room that I'm using needs to be sprayed. They want to disinfect this room, so let's just pause for 3. Right, I'm back. Let's now proceed with our lecture. So I was talking about this first few lines of code. These first few lines of code. Nobody is confirming that he or she is seeing the screen. Please confirm. Please confirm that you are seeing the screen that I'm sharing with you here. Do I have anyone here, or I'm left by myself? Do I have anyone here? Are you there? Are you there, good people? Are you there? Okay, anyway, let me just proceed, and I hope that you will see this on YouTube if you aren't getting the content clearly. Right, so I've talked about the data segment, and in the data segment, that's where we declare variables, and that's where we do. Yes, I'm happy that Dennis Peary is there, and Arnold is there as well, because I'm seeing that he's typing. Just finish up typing whatever that you're typing, because so that I can confirm. Yes, Arnold is there. I'm happy that I'm having people around me in this room. Right, so that's the data segment. In the data segment, this is the code that we're going to write. You put your own string and make sure that you have this $sign, because we're going to use this $sign to check whether we've reached the last character or whether we've reached the end of our string. So you can observe that from this code, we've hard coded the string to be converted from uppercase to lowercase. We've hard coded this code. So the takeaway that I gave you is supposed to replace or remove this hard coding and allow the user to enter his or her own string or user input. So that's the input, that's the data segment code, and then from there we go to code segment and data segment initialization. So to tell our assembler that we are starting a new segment, we tell it by saying dot data or dot code. So by dot code, we are telling our compiler to say every instruction that is going to start from after dot code exists within code segment. So code segment begins here. Code segment begins here. So from there, inside the code segment, we are now defining our own label. So the label that we have defined here is start. So we've defined our start label. So you can see that on segment definition or segment writing, what we have done is we said dot code. That's the syntax. Just say dot code. But if you want to give it a different name, that's when you use the assume directive. So here we say dot code, and when we define a label, we say start, and then we put colon. So we have started, we have typed our label, and after start, we write the following instruction. So I am sure that some of you are typing this code. So we say move AX. So what we move to AX is everything that is in data segment. Everything that was in data that is in data segment. So we say at data, and then its data is the source, and in AX we put AX is now acting as the destination, and we then move the data from AX to data segment to DS. So that's how we initialize data segment. That's how data segment is initialized in ALP. Right. So after that, inside the code segment, we now define another label, and this label is now called uppercase. This is the uppercase. So if you are confused, just wait for me. I will start to type this code from scratch so that you can follow as I will type. You are saying no sound, no sound. Let me just, are you getting sound? Please confirm whether you're getting the sound or not. Confirm whether you're getting sound or not. No sound. Okay. Let me try to recall. Let me try to
You are now unmuted.
Right, can you hear me now? Please confirm. Right, okay, thank you. So we have to move back. These things. I now have to move back to where I started, or to where we resumed. So what I was doing, what I was saying is, I was talking by myself. I hope I was recording somewhere so that I can replay it. But anyway, I still have the energy to repeat what I've been saying. I was saying to tell the assembler that our data segment begins here. We say dot data, and we write every code that is relevant for the data segment. So in data segment, we deal with the data, and data is stored in a memory location, and our memory locations are defined using variables. And what we have done here is we have defined our variable called string, and it's of size byte, and it's initialized to this value. And make sure at the end of the string we are having a $sign, which is telling us that we have reached the end of our string, or we have reached the last character of our string. So those two lines are the ones that are important, and those lines in green, they are just comments telling the user what we are actually doing with this code. So we've done string variable declaration and initialization. So that's what we've done in the data segment. And if we want to open or start writing the code, we now open the code segment, and we write this code, which is saying dot code. So dot code segment begins here. So to say every code that exists within an ALP exists within code segment. All other instructions or all other lines of code, they may be defining the data or telling the assembler what to do. That is, may have directives and other kinds of lines of code. So what we are doing here, we are telling the compiler that our code, after this dot code, we are going to have lines of instructions or lines of code to be executed as instructions by the assembler. So from there we define our label. Our label here is called start. So the colon there is just telling us that our start label begins after this colon. And then from there we write this code now. We now do data segment initialization. So in data segment initialization, what we do is we take AX as the destination, and then data is the one that is taking everything that was typed inside the data segment here. Everything that was typed in here is the one that is going to be put into AX in this line where we are saying move AX comma 8 data. So we're taking whatever that is in data segment, we are putting it into AX, and then we take data from AX into DS, which is data segment. So that's how we initialize. These two lines are the ones that we use to initialize the data segment in ALP. I hope everybody is understanding this as we proceed. Please confirm you are getting this correctly. All right, you are getting it. Assume you're getting everything right. So that's it. That's what we have in the code segment. But our code segment does not end there. We then proceed and write the following instructions. What we are doing now is we now define another label called uppercase, and in this label, the code surrounded, or the code within this label, or the code after this label, is going to check whether we have reached to the last character of our string, or we have we just want to check whether we have reached the last character in our string. If we haven't reached the last character of our string, what we do is we then get the next character in our string, and we check whether it's uppercase or lowercase. If it's lowercase, then we convert it to uppercase if we are converting it to uppercase. But if you are converting to lowercase, if it's uppercase, we then convert it to lowercase. So in this case, we are converting to lowercase. So we check whether it's already lowercase or is in uppercase. And if it's in uppercase, it means we need to convert it to lowercase. But if it's in lowercase, we don't need to convert it to lowercase because it's already in lowercase. Then here we write this. So since I said in uppercase label, we want to check whether we have reached the last character or not. So what we do is we check the value that is stored at a certain address, which is bx. We check the value that is stored at a certain location stored in bx. We compare it with our last character, which is the $sign. So as I said earlier, that the $sign is the one that we are using to check whether we have reached the last character of our string or we haven't reached. So here we are comparing. If we compare the value at a memory address stored in bx, we compare it with the $sign. But how do we compare these values? How do we compare these values? If you would want to check, you observe that $sign has got a numerical equivalent value. It's got a numerical equivalent value, and each and every character that we have has got its numerical value, which is equivalent to that character. So here what we are doing is we are comparing the numerical value of $sign with the numerical value of a character stored at memory address stored in bx. So we are checking whether we have reached the last character or not. I will show you when we start typing the code, when I start typing the code, and I hope you are typing if you want to be advanced or if you want to move ahead of me. So from there, what you do next is we check. We now act according to the results of our compare instruction. So if the last character is equal to $sign, or if the last character is $sign, then we jump to a label called done, because we are done. We have reached the last character. We have reached the last character of our string. But if we are not done, if we haven't reached the last character, we then compare a byte stored at location bx. So byte ptr, it stands for, it's just telling us to say the size of the data that we're going to get at this address is of size byte. So nothing else. It's not special, it's not complicated. Byte ptr is just telling us to say whatever the value that we're going to get at this memory address is of size byte. So we now compare the value that is available at location stored in bx with a. So what are we actually doing? We are checking if it's a lowercase letter or an uppercase letter. So I will open a certain document for you. I'll open a certain document for you so that you check. You can so that you can see the ASCII codes. The ASCII table. Let me show you the ASCII table. I want to show you the ASCII table. Right. And describe it theoretically before we jump into the code. So what are we saying? We are checking whether our character is lowercase or not. So we can see that here we have our, let me zoom it so that I can see it. Please confirm whether you are seeing this or not. Confirm please. Confirm please. Confirm whether you are seeing this table clearly. Right, clear. Faith in Love said it's clear. Faith in Love said clear. Dennis confirmed. Tererai Bo Sagamnandi and Yumbe. So what we are doing is we are saying we want to check whether the character is lowercase or uppercase. We want to check whether the character is lowercase or uppercase. So what we are doing is, right, so that's what we have. And let me now open the table here. We say, you can see that we have 97, 98, 99, 100. So it's moving, it's incrementing from 97. and these are the lowercase characters A, B, C. So A is 97, B is 98, C is 99, D is 100, E is 101, F is 102, up until we get to the lowercase Z, which is 122. So we are checking anything that is within this range from 122 going backwards to 97. Anything within that range is smaller case or lowercase. And you can observe that everything that is below 97 does not need to be converted to lowercase. It doesn't need to be converted to lowercase because it's either an uppercase or it's a character. It's another character which is not within alphabetical characters. Anything that is above 122 is a character, and it doesn't need to be converted to lowercase because it's already in lowercase. You cannot say we have an ampersand which is in lowercase or which is in uppercase. An ampersand is an ampersand. It doesn't matter you are typing in lowercase or in uppercase. You see? And then our uppercase characters, they start from 65 and they increment up to Z. From 65, 66, B, 67, it's C, 68, it's D, 69 is E. We go up until we get to 90, which is Z. You see this? So what happens now is, in our code, to check whether a character is a lowercase, we just check whether it's between 97 and 122. But since we are typing in characters, we can compare, we can use Z and A. That's what we are doing exactly here. So we are saying compare the character that is at location in BX with A, and then the result of this comparison, if we jump to OK label, if the character at location BX is below 97, it's because A is 97, if not mistaken. A is 97. Yes, A is 97. You can see it here. A is 97. So if it's below 97, it means it's not it's something which is in uppercase. It's something which is in uppercase. So we jump to OK label, and then from there we go and check again. So you can see that we are checking characters. We want to have a range from A to Z, so that's what we're doing. We then check again whether that character at location stored in BX is, we are just comparing, and the result is going to be determined and action is taken here. We jump if above, jump to label called OK if the character is above 122. So why are we saying jump if above? Why are we saying jump if above? So you can see that we are jumping if above because the values, our lowercase values ranges from A to Z. So they range from 97 to 122. So if the character that we have is within this range, that's what we have done here. If it's within this range, it means it's already a lowercase, and we don't need to convert it. So that's why you can say lowercase characters exist within the range A to Z in lowercase, or from 97 up to 122. So that's how we check. That's how we check whether a character is a lowercase letter or it's an uppercase letter. Now from there, we now convert the value or the character to uppercase. So this is the code that we write to convert our what? The character located, the character stored at location in bx. We just multiply it by this value. This is the exact value that you use to multiply it with the value that is stored at bx, at location bx. But this multiplication is not the normal one where we say multiply, but we use the AND instruction. So the AND instruction is the one that is combining this value and that to convert the value or the character at this location to a lowercase. Right. So let's go ahead and check other labels like the OK label. In OK label, we write this instruction. We increment the value of bx. So what you are doing here, we're just moving from one location to the next location so that we get the next character. So here we say we've checked this character and we've observed that it's okay. And then if you have observed that it's okay, let's move or let's increment the address and get the character that is located at the next address. And then the character that we get from the next address, after getting it, we jump to uppercase. And what happened is the value of bx has changed, and bx is having the address, not the actual value. So we've incremented the address so that we can get the value at the next address, and the value at the next address is our next character. So we are processing our string character by character. So here we're saying go and check if we haven't reached the last character. That's what we are saying here with this code. Now jump to uppercase. So we are now repeating the same process. We go back again to uppercase and then we do whatever we want to do. Then we have the done label. The done label is the one that is telling us that we have completed the process of converting our lowercase to uppercase or our uppercase to lowercase. I can observe that there is a message in the chat. Right, that's fine. So that's done, and then we have we now need to load the effective address or the memory address of our string to dx. That's what we are now doing in the done label. And then after that, we are now requesting the display, that black screen, using the 09h function being moved to AH. So whenever you move 09h into AH, it means we are moving a what? We are requesting for that black screen as the display or as the output screen. And then int21 is used to execute or to grant permission to all requested functions. So execution interrupt function int21h. So from there we then get our output. So those that are going to watch it from YouTube, please subscribe, like, comment, and share. Don't forget to click on the notification bell. So we are done with converting uppercase to lowercase, but the next thing that we want to do is we want to write it, execute it, and check whether we have done it correctly or not. So let's open our emulator. Let me search my emulator here. So let's all open our emulators. Right, so this is our emulator. This is the emulator that we have. we all have the code now. Let's let me just clear this up. Just wait a second. Right, from uppercase to lowercase. Right, so what we do is like what we have been discussing. Like what we've been discussing. I have what have I done? I once instructed you to remove everything. So I'm going to write here a comment. I'm going to write a comment here. Something.
You are now muted. You are now unmuted.
I'm sorry, I'm losing connection this side, and I hope that everybody is going to gain access to whatever that I'm saying here when we upload this on YouTube. If we face challenges, I will redo this lecture with you, because I feel that the concepts that are covering here are important for you if you become one of the engineers in the field, or one of the engineers in the industry. So what we now want to do is we now want to write a code to convert upper case string to lower case string. Right, so what we have talked about and discussed was about converting a string, converting converting an uppercase to a lowercase to uppercase. That's what we have been discussing about, lowercase to uppercase here. So the main business is here. Lowercase characters exist in the range that A to Z. So if it's a lowercase, then it needs to be converted to uppercase. So that's how we do that. So let's now type the code. Let's not type the code. Let's not type the code. Right, so the code is like this. We have removed everything, so we can start by saying dot data, and then we enter, we say string. We are now defining our string, and then we say data define byte, and then we put the string. I said Shexa is a world class engineer at Chinoy University of Technology. You can observe that I'm typing the string in upper and lower cases, so maybe that's what you want to get rid of. You don't want to have lower cases mixed with upper cases, or upper cases mixed with lower cases, and you want only lower cases, or you want only upper cases. So that's what we are dealing with here. So what you do now is we are done defining the variables, done defining variable declaration. So I can put a comment here. Let me put it here and say variable. That's a comment now. Variable declaration and initialization. And then from there, what you now do is we get into the code segment. So we say dot code, and then in the code segment we have our start label, and in start label the first thing is to let me do it this way: initialize the data segment. So initialize the data segment, and to initialize the data segment we move to AX what is in data, and then we then move to data segment whatever that was moved to AX. We are done with what do we call it, with the initialization of the data segment. Now we declare our labels: lowercase label. Previously we've talked about the uppercase, so it depends with whatever that you will be doing. And then here we say that I'm just pressing what tab. Then we compare the value in address stored in bx with the $sign to check. What are we checking? We are checking whether we've reached the last character. So here, checking if we have reached the last character of our string, or maybe just say we are checking whether we've reached let me just leave it like that. We are checking whether we've reached the end of our string. And then what we do now is jump if equal. Crowd can equal, jump if equal. So if the value at address stored in bx is equal to $sign, it means we have reached the what? It means we are done, because we have reached the end of our what? Of our string. So here we are just saying what? We are saying if we have reached the end of jump to a label named done. This one, that's what they're saying. Right, let me zoom it. Try to zoom it. Okay, so we jump to done, but done is not yet defined, but we will define it. Now what we want is we want to compare. Here we're converting it to lowercase from uppercase. From uppercase to lowercase. Is no like it. I hope ndichiti nevanhu bana. Wezi zvimboitika bana zvino tinosara ndega. Yes, as to have people. As to have people around me. As to have people around me. Are you there? Are you there, ladies and gentlemen? Are you there? Svanda is typing. Yes, it means I'm having someone. Yes, I'm happy that you are still around me. I feel so secure if I still have people around me. Thanks, guys. Now that we are trying to jump, we're not trying to jump to done, but done is not yet declared. So what we do now is we want to compare now. So it means if it's not equal, it's not going to jump, but it's going to run the next instruction. And the next instruction is compare. We compare what? A certain byte. Byte beta stored in bx. Then we plug that. And then here we want to check. So here we want to check whether it's already in uppercase or it's in lowercase. So here we check. Let me put a comment here. Checking if the character is in uppercase. Right. So uppercases, they exist within what range? Let me open the table. Uppercases begins here up to there. So we are checking whether it's between A to Z. If it's there, then it means it's okay, right? So we say compare that with A in capital letters. So A in capital letter is different from A in small caps or in lowercase. Then we jump. If it's below A, what does it mean? If it's below A, it means it's a character like age, space, and so forth and so forth. So it doesn't need to be converted. It doesn't need to be converted. We're converting to what? Right. So if it's below A, it means it's a lowercase. It's a character which doesn't need to be converted, because anything below A in capital letters is not a small letter, is not an uppercase, but it's something else which doesn't need to be converted to lowercase. And here is the list of those characters. Can you convert a hash, a $sign, a percentage to uppercase or to lowercase? You cannot. So anything less than A, we don't need to work with it. So we say jump if below. We jump to where? To OK. Right? And then we check whether the character is what? The character is Z. We compare with Z. and then here we jump if above. Now if above, what does above mean? It means if it's above here, it's anything like that. Anything above here is a character or is, so we are just checking whether it's in uppercase or not. So we can observe that anything above Z is not an uppercase. So we jump if above to okay, sorry. Right, so now we write the code to convert the character in memory address to lowercase, because we've checked and observed that the values that we have, so if the value is above, it means we jump to okay, because we don't need to change to convert that to lowercase. If it's below, we jump to okay, because we don't need to convert those values to lowercase. So here, if we do not jump here, we get to this instruction and we compare, and if we don't jump here, we then do what? We do the conversion now. Now converting, done. And previously we said and, but now we use or, because we want to convert this to lowercase. Byte Peter, the value that is at this address is the one that we want to convert. We add it with 001 1 2 3 4 5 in binary values, and then from there what we now need is we need to type in. So you can observe that here we used or, and the value that we have used here is the opposite to the value that we used when we talked about the end. So here you put a 0 and you just flip-flop the zeros and the ones. You just exchange. Where there's a 0 you put a 1, where there's a 1 you put a 0, and where there was an end you put an or. We are done. Now let's type in, because we've talked about the OK label, we've talked about the done label, but we do not have these labels. Let's now write these labels. Let's now put these labels. Let me check if I still have people around me. Terrorize Banda. Yeah, I'm happy that you are there. Yeah, let's now put the OK label. Okay, and this is how we put the OK label. This is how we type all the labels. Then we now want to go to the next label, to the next character. So what do? We increment the address EX. After incrementing the address, we jump to what? To lowercase. We jump and check. We jump to lowercase, where we are checking whether it's lowercase or it's uppercase, and we are acting. Here I said lamp instead of jump. Here, right? So we jump to uppercase. So we are going to we go and check if we haven't reached the last character of our string. That's where we have our lowercase. In lowercase, then we also convert it. We convert the characters, and then once we are done, we have talked about another label. What's the name of the label? Done. Right. Done is now is supposed to tell us the output. Now it's now supposed to give us the output, to print the output. So we type our done label, and then we say it's now supposed to print out the output. So to deal with the string, if you want to print or deal with the string, especially printing, we use dx. So we load the effective address, and I'm sure you know how to load the effective address to dx in another way which doesn't use LEA. And the address that we want is string. So dx stores the address of the strings. Dx is now storing the address of the string, and then we move our AH, we move 09, and I've talked about 09H, what it means. Move AH, right? This one means what? We are requesting for the black screen output, and then we say int 21 to grant permission. Giving a code. Hello? All right. So int 21 is now granting permission, and if we want to wait for user input, or if you want to, let's just run it and check. Right, our string is that we say single step is it's going to run. Not supported, not unknown opcode skipped. What's that opcode? Let's just run it. It's just a long string which is being processed here. Did you put the $sign by the way? Let's check. Yes, we have the $sign, but I think it's just because the string is a bit long. Let's wait and see. It must have terminated. I think there's something wrong with this. Let's just look at it and check. Right, somebody's asking the secret behind the value that we have typed here. This value. This is the value that is being, when we have an OR, it's more like we are adding this value to the value that is stored at an address stored in BX. So what we'll be doing is more like multiplying, and if we multiply we get a certain value which is the same value in lowercase, or which is the same value in uppercase. So we've observed that if we try to run it with only this, it will run and run and run and run and run, and will never stop. As we have observed here, it will run and run and run and run, and will never stop up until we stop it. So let's try to put a code to pause the black screen. Let's try to put a code to pause. So we say what? We say move. So to pause the screen, we just request for user interface. So we say h comma, we put a 0, and then we say int 16h, and then we say int move a x c00h, and then we say int 21h. Let's try and run this. Run. Okay. All right, it's okay. It's because we haven't ended our start, so we have to put end start there and try to run it again. right? Right, the output is now there. Shexa is a world-class engineer at Junior University of Technology. Our text is not in lowercase, all in lowercase, all in lowercase, all in lowercase. So if we want it to be in uppercase, where do you think you are going to change? Let me speak to someone here. If I want to change this code to uppercase, where do I change? What do I change in this code? What do you think I need to change in this code? Let's talk. Let's discuss. Where do you think I'm going to change in this code if I want to convert the string to uppercase? And I think we've discussed it. That's the first phase that we have talked about in this lecture. Where do you think I'm going to change if I want to change this code to convert from lowercase to uppercase? We'll do the experiments. Just vomit whatever that you are having in your mind. Let it come out. If it's wrong, then the demon is gone. But if it's correct, then we pray to God so that we keep the correct thing in your mind. Let's discuss. Mana, I'm still running. Okay. Come sudo red bo. Ndakuwe ndrambe. So ini zvandeta mai kana vanhu vasiri kuda ndinongoda iso. Ndinoona kuti vanhu havasi kulava. Online curve change from lowercase to uppercase. Okay. Thanks. Ndanda kuda kutoita zvinhu. Online curve. Okay, here no change from lowercase to uppercase. Okay, yeah, good. Nanoketa. And then I wrote uppercase like this. Those are whatever tables are. Is this what you mean, Taku? Terra is saying land now or Tunesa end. Okay. We had Tunesa uppercase against Atisa uppercase yachimbo tester. Wrong. Why? Because here to jump and it to lowercase here. We can get it to uppercase. This is Torona Plaza. Uppercase. Okay. But now, what happens? Let's see. Let's wait and see. Each chabud. But still, it's converting to lowercase. So what are we supposed to do? Let me check some responses. Once it knows the end, this one. Kroti yatakudzwa yaramba. Tanyora kuti uppercase zvaramba. Takutedzera terera. Since isna ma error yatipata daiso, we can just say undo. And start. Just run a lowercase. This one. And it knows the end. Just put end right. To run. To not irkuita see. Okay, let's run it and check the output. Look at the output now. Look at the output. Shexa is a world class EAT universe. Man, whatever the so let's just check and analyze the output with our code. I want you to see something, and I want to learn as well here. So this is our output. Can you observe something here? Right, S is already in uppercase, right? So it was eliminated, and is a world class is in lowercase, and everything that was in uppercase was eliminated, and we have 8, and everything that was in uppercase chinoi there is eliminated, and all those left in lowercase are the only ones printed. So we have eliminated uppercase letters. So what have we done? We've multiplied. Let me use the term multiply, because if we say multiply and get a 0, we don't print anything. That's what was happening. A 0 by a 0 is a 0. So an end is when a 1 and a 1 is a 1. That's when you only get 1. So that's why we have omitted uppercase letters here. So let's get correct answers. We are moving in the correct direction, right? And Terrace Banda is saying 1101111B. What are we supposed to do with that 11011B? What are we supposed to do with that? Did I? I think you are in the correct direction, but we just want full info. Oh, we replace it with that. Okay. So to replace apana. To what is a 0 1. What is it? So to some 1 5. 1 2 3 4 5. And then you put 1 1. Don't all that. I mean, let's just check. Oh no, Keta score man. What have I done here? Okay, I didn't stop this one. I didn't stop that one. Okay, let me emulate this one. Alright, let me just save this at that point and then run it. Let's check. It's giving us our input and nothing was changed. Huh? Nothing was changed. This is the same input that we wrote here. This is the same input that we wrote here, and it's being reproduced here. So it's doing nothing. This code is just reproducing the same input. So what are we supposed to change? What are we supposed to change? I think few things are left now. We now need to change few things. And there is change. Chinoi became uppercase. Chinoi was already uppercase. Here you can see Chinoi was already in uppercase. So there's no change. It's reproducing this to that. So there's no change. What do you think you are going to do? Yes. Terra is going with us. That's how we learn. You learn through thinking and solving problems. So we are supposed to do something here. We are supposed to do something. and that something is changing here, A and Z. But now, is this correct? Let me press here and say A. And then Z here. Right. Let's run it. You observe something here. You observe. We are moving in the correct direction. That's what I love. But you see something. Let's run it. We learn through experiments. Right. It's now in uppercase. Shexa is a world-class engineer, University of Technology. Alright, so that's how we do it. But now your code needs to be very smart and needs to be structured and with correct terms. Here you need to type uppercase, because since these are the labels or user-defined labels, you can put anything, you can put your name or anything. So that's how we do it. That's how it's done. That's how we go about it. So we have written a code which converts uppercase string to lowercase string, and we have written a code which converts lowercase to uppercase. I hope you were following, and you now know how it's done. You now know how this is done. Right, thank you very much, ladies and gentlemen. Let me applaud you for being here, and let me as well encourage you to visit the channel, subscribe, click the notification bell, like, comment, and share. Goodbye. Enjoy the rest of your day.